Oh, you can stay in there. A true Silicon Valley garage startup in Palo Alto, like a few blocks from HP.
Just don't bump it.
I will try not to bump it.
Yeah.
So, who are you?
I'm Ben.
Yeah.
Yeah. Ben, founder of K-Scale Labs. We're building humanoid robots. That we're going to open source this, so the goal is to have a humanoid robot that anyone can make and just have in their house. And hopefully in a few years there's billions of these. That's the goal.
So you started 2 months ago.
Yeah, so I got into YC, and Matt and I had met like a week before I got into YC, and we hit it off, and I was like, hey Matt, I told YC I'm going to build a humanoid robot. You want to move to California with us, or with me, and work on it? And then I was like, yeah, sure. And so we kind of got started, moved into this place January 17th, so we had to clean out the whole garage because this was all unwalkable.
And you used to work at Tesla?
Yeah, I worked on the Tesla autopilot team.
Yeah?
Yeah.
Which is also the Optimus team as well, or are they separate teams still?
It at the time it was kind of like Optimus was getting started, so all the perception team was formed out of the autopilot team.
Yeah.
So yeah, I worked on one of the models that was one of the first like foundation models that went into the Optimus.
Very cool.
The occupancy network.
So what's the state of your robot right now? Because it's 2 months old. You've been training it to do various things. Tell me what it can do that you're proud of.
Right now it can stand without falling over. So that's we're very proud of that. The goal is to just iterate on the hardware as quickly as possible. That's why we got 3D printers. So this is like V3 of the robot. And yeah, the nice thing about 3D printing it is we can just like make V4 in a couple of days. We just finish the design. Like we need to do a few different things. Like we need to change the motors on that. Like these actuators are probably a little too weak for like what we're doing. That's kind of like stopping us from like standing without falling over in more positions. Yeah, we need to hook up these servos to the controller because these currently don't open and close. So yeah, a lot of like very like they seem like small things, but this is kind of the stuff that stops you from making something work well. But we're hoping because it's the two of us, and well, Pablo's going to come, and we'll have a pretty good understanding, and we'll be able to just like make something that works well, be able to implement some of these cool papers that are coming out, and then we'll just like put it out there for free for anyone to do.
That's cool.
Yeah.
How long do you think it's going to be before something like this gets into my house and can, do my clothes and my dishes and clean my windows and clean my toilets and all the things we'd want a robot like this to do?
Yeah, I mean, I started this because I was worried that this was going to take too long, and I want this to be like now, personally. Like, I wanted to have this in my house, so this will be in my house when I can convince my wife to like let it be in our house.
Yep. It's a little noisy, a little well, you said it has trouble standing right now, right?
It has trouble standing. That's why it's good that it's smaller, because if you don't want to fall over on someone, we don't have any pets, fortunately. But yeah, basically, like we wanted to just use this as a test bed to like implement some of the recent papers that have come out. So there was one paper from this guy Chung. He's Stanford PhD called UMI, Universal Manipulation Interface.
Yeah, I think I retweeted that. That's what we shared it. Yeah.
Yeah, so we actually designed these grippers basically off of Chung's design. There's some slight modifications. Like we talked to Chung about his grippers a little bit. He came over actually a few weeks ago and gave us some advice on how to do it well. But yeah, like the camera is center mount in these ones, whereas Chung's was kind of off to the side, which makes it a little bit easier to do. Like when you're coming at something, the distance is kind of a true distance, because if the camera is center mount, I don't know if that makes sense. But,
yeah.
Whereas if it's like off to the side, you kind of have to come at it like that. So the ML might be a little bit easier, do a bit better because it's center mount. But other than that, this is like basically the exact design from Chung's grippers. So then the question is like how quickly can we implement the UMI paper. TBD. I'm pretty confident. We're pretty smart, so yeah.
Very
hopefully,
cool.
and then we'll have chunks stuff.
Tell us about this tech stack. How does this see? Does it build a neural radiance field of the world around it? Tell me a little bit about. Tell me about the technology that you're trying to build in this state-of-the-art kind of robot.
Sure, yeah. So our perception stack is, we're just kind of trying a couple different approaches. We're trying something like a occupancy network based on when you are, there's this data set called EgoExo. That's a good example of data set. And essentially, if you have several cameras looking at a robot from different angles, you can use those cameras to supervise the scene kind of from another angle, and that gives you you can do occupancy from that, just from the other cameras. Sorry. So yeah, basically that's one approach we're trying some foundation model type stuff with EgoExo data sets. We're also doing a VLM model that we actually have trained it. It's looking okay. It's just
you've trained your own model, or are you using something like Mistral or something like that?
We're training our own. The constraint is it has to run on the computer in the robot, and there's not this is kind of why I wanted to do both things. Is kind of have to think about them probabilistically. If you want to train a model that runs on the computer in real time, you're kind of constrained with the types of models you can train.
Yeah.
So yeah, but the VLM model we're training is, or we trained and it looks okay. And then probably we won't use the VLM directly. We'll probably use some intermediate representation, but using text to supervise the visual representation is probably good for the visual representation.
Now, there's some robot companies that just got $670 million, right, to build a humanoid robot.
Waste of money.
Waste of money? Why is that?
I don't know. You feel like I was in self-driving, so I remember a lot of self-driving companies raising a lot of money and kind of failing to deliver. And I feel like it's largely the same thing. Are humanoid robots $1 billion a year revenue thing next year? Probably not.
No.
So if
by 2030, probably.
Yeah, 2030. Yeah, but then it's kind of I don't know. I just think it's a bad bet to say that Figure or whoever is gonna be the only robotics company at that point. And I feel like we kind of proved that by building our own in the garage with two guys. The hardware is really not that hard, and I don't know.
Now your grippers have 2 fingers, right? The Optimus has 10, like a human does. What's the difference, and what's the complexity as you go up to more and more dexterity on the hands?
Yeah, it's an open question. I think you make trade-offs with using a dexterous hand. The actuators are weaker. If you want to get really true human level hands, the only really good one is the shadow hand. It's got 38 degrees of freedom or something on it. But if you're just kind of mimicking human appearance hands, I don't know that there's a big advantage to having 5 fingers versus 2 fingers. Actually, this is a question that we discussed with Chung when we were thinking about what grippers to use, and he's yeah, you can do 95% of what humans can do with just pinchers, and he demonstrated that in his paper. So yeah, there's a couple papers doing that exact thing as well. Very
cool. This is all off-the-shelf components, other than the 3D printed pieces that you're doing.
There's this supplier in China. They just sell these nice MIT Cheetah actuators. Pretty much commodity. Yeah, this is a 6-to-1 reduction ratio, so it's just a quasi-direct drive. Yeah.
That's awesome.
Yeah, there's 4 different sizes, so they're just different torques. And yeah, these are it's kind of amazing. I found out about these from watching this guy's YouTube video, and he did a review, and I was wow, those are great actuators. Could probably use them to build a robot, and so that's what we did. Yeah.
That's cool. What are you hoping to teach it to do for you?
For me personally?
Washing dishes or You know, when this gets done enough and is in your house and your wife accepts it, what are you going to have it do?
My wife always leaves like soda cans around, like half-empty soda cans, and I always end up going and picking them up. So I would like to have a robot go and pick them up for me instead, because might save our marriage.
That's awesome. Well, thanks so much. What do you call this robot, and where do I learn more about you, and where can we watch the development of this robot and get involved maybe?
Yeah, absolutely. We're gonna open source this. I mean, we're doing YC right now, so I'm gonna launch it on Hacker News once we've kind of finished the design. The company is called Kscale Labs, kscale.dev. We'll post Twitter updates. Matt posts a lot of Twitter updates.
Very cool.
I don't post a lot.
Very cool. Well, thanks so much. I'll let you open the party up and show this off. So thanks.
Thank you, yeah.